4.5 billion years ago, Earth was not the vibrant blue world we know today. This is the story of its deep history, the Precambrian. To understand our home, we must first look beyond it, to the chaotic beginning of our solar system. In the solar nebula, dust, gas, and rock began to clump together, driven by gravity. Over millions of years, these violent collisions aggregated enough material to form a protoplanet. The young Earth was a product of violence. Heat from accretion, compression, and radioactive decay rendered the world molten, a vast sea of liquid rock. This first, most turbulent phase of Earth's existence is known as the Hadean Eon, a time of fire and devastation. The atmosphere was thick with toxic gases, and the surface was a churning ocean of lava. Asteroid bombardment was ceaseless, leaving no place untouched by cosmic violence. Then came the defining event of the Hadean, a colossal impact with a Mars-sized body. This collision not only remelted the planet, but hurled massive amounts of material into orbit, forging our solitary moon. This giant impact fundamentally altered Earth's composition and stabilized its axial tilt, setting the stage for future transformations. Slowly, over hundreds of millions of years, the planet began to cool. As the temperatures dropped below boiling point, water vapor trapped in the atmosphere condensed, unleashing biblical rains that formed the first deep oceans. With a stable crust and liquid water established, the planet entered the Archean Eon, the era where the incredible story of life truly begins. The oceans were vast, the atmosphere still lacking oxygen. Here, perhaps near these very hydrothermal vents, rich sources of heat and chemicals, the fundamental building blocks of life first assembled. The first true planetary engineers were simple microbes. Cyanobacteria, living in massive colonies called stromatolites, began harvesting sunlight, releasing oxygen as a waste product into the environment. For over 1 billion years, this slow biological process gradually accumulated oxygen. It was a silent revolution, waged by the smallest organisms, with the biggest consequences. As the volume of free oxygen grew, the Earth entered the Proterozoic Eon, initiating the most profound environmental shift in planetary history. The Great Oxidation Event saw oxygen levels skyrocket. This sudden increase poisoned the existing anaerobic life, yet it fundamentally altered Earth, changing its skies from hazy orange to the familiar blue. The oceans lost their dissolved iron, and crucially, the ozone layer began to form, shielding the surface from lethal ultraviolet radiation and opening new habitats. The Proterozoic was not smooth sailing. Several times, possibly due to imbalances caused by the new atmosphere and continental drift, Earth plunged into extreme glaciations, the snowball Earth events. Ice covered nearly the entire planet, from pole to pole. Only volcanism and a massive buildup of greenhouse gases could finally break the grip of the global freeze. Emerging from the ice, a new evolutionary frontier opened, leading to the dramatic final chapter of the Precambrian. In the period immediately preceding the Cambrian, life experimented with multicellularity. The bizarre Ediacaran biota, such as the segmented Dickinsonian, represented the first large-scale, complex life forms on Earth. After 4 billion years of transformation, the stage was finally set. The Precambrian had built the framework, a habitable world ready for the explosion of biodiversity that would define the next great era.